have one. Today I'm mainly focused on talking about an example named the Enskambi's contact. Yeah, the Enskambi is the name of a statistician whose full name is Francis Enskambi, and the contact it means it's a music. It's a word from the music, which means the four instruments are played together. So, in our example, we're going to focus on the chord, which means four. So this is an example developed by statistician Francis Enskambi in 1973, and he developed this example to explain three things. The first is the limitation of some basic statistics. Like the mean value, the variance, the mean value, the variance, maybe the correlation coefficient.
I'm sorry, under mean, what's that?
The average.
Yeah, under mean. Underneath the word mean. What did you write underneath?
For variance.
Variance.
Variance. And the correlation coefficient, and also maybe the regression line. And for second, it will show us the importance of data visualization, or maybe the graphs of the data. And the third, this example could also show the impact of the outlier. Yeah, I will explain what is outlier. Outlier is if you have a data, most of them are distributed here, but there is another data we call an outlier. It's far away from the data set itself. So the Enskambi contact, because there is a chord which means four, so we have a four group of data, and in each group we have two variables. That is the x and y in each group. So for our data set, we have for all of the group we will have the same average value of x, same variance value of x, almost the same value of y, of the average of y, almost the same for the variance of y, and almost the same correlation coefficient between the x and y in each group, and also almost the same regression line for each group. However, in most times, some scientists or some people, they will only use those basic statistics to get the information from the data, but this example shows those basic statistics could not provide enough information of the data set itself. So I will show what the full data set looks like. For the first data set, it's just like some scatter point, and with the regression line here. So
what kind of line is that?
Regression line.
Graduation?
Regression.
Can you write it down?
Regression.
Can you write it down?
It's right there.
Oh, regression.
Oh, regression. Sorry. Regression line. And for the second group, the x, y, they have some relations, but it's not linear. And for the second group, most of the data, they are distributed linear, but there is an outlier here. So the regression line changes a little bit. And for the last group, most of the data are here and of the same x, but they are outlier here. So the regression line will be like this. So as you see, all of the data, they are distributed in different ways, but their basic statistics are almost the same. So this explains the limitation of the basic statistics. This is our first point. And for the second point, you see those graphs, well, maybe we call the data visualization. They can provide very good information. So before we do some statistical analysis to plot the data out to see what the data looks like, will help us to choose which kind of statistic we want to use. And the last is for those two groups. You see, for most of the data, they are in the same line, but because they are in an outlier here, so the regression line will change a little bit. And also for this data set, most of the x they are the same, and the y have no relationship to the x. But because of this outlier, the regression line looks like the others. So the last 2 points, we know that we should be very careful when we collect the data, and we should double check the data we collect to make sure every point is correct. Because if you get an outlier or wrong data, your statistic analysis will fail. Okay, thank you.